So the easiest way to check for symmetry is to graph these. So if I type this in my calculator, it moves down 3, and the x to the 4th just makes it kind of more flat here, and then it goes up. Actually does a little wiggle down here, but it's hard to see unless you really zoom in. So is there any symmetry? The symmetry is yes, y-axis symmetry. Okay. Another way to test this algebraically is if I were to plug a negative x in here for x, and I put it to the 4th power, that makes it come out as x to the 4th, which is exactly the same as what I started with. So if a negative x gives you the same thing that a positive x, which is what we started with, gives you, so realize what's happening is this negative x is giving you the same y value as the positive x is right here. So that's what this is saying, is that a negative x has the same y value as a positive x does. And so when the negative x plugged in gives us the exact same equation as what we started with, we know it's symmetrical with the y-axis. So same idea on this one. I can graph it. That's y-axis symmetry, because I can fold it over the y-axis and it's exactly the same. Or if I plug in a negative x, the absolute value of negative x is a positive x, which is exactly how we started. And so again, what that means is for a positive x and a negative x, they have the same y value. So on this one, x equals y squared. So this is no longer y equals x squared. This is x equals y squared. So this is a parabola that opens on its side, which means this is x-axis symmetry. So if I replace the y, so realize on these ones I replaced the x's. This one, if I replace the y with negative y and I square it, negative times a negative makes a positive, that gives me a y squared. So when I replaced it with a negative y, so here's what's happening. I have a value for a y, it gives me an x out here. If I take the same like negative y and positive y, I get the exact same x value out. So that's another way to test for x-axis symmetry. On part D, if I graph this, negative 1, I go up 1 over 3. So if I look at my graph, there is no symmetry. Okay, and again, if I replace this with negative x, I would get y equals negative 1/3 x minus 1. Well, that's no good. That's not exactly the same. And if I replace y with negative y, I don't get the same thing either. So that's not x or y axis symmetry. And if I replace, so that's not it. So the easiest way is to look at the picture. Part E, that's a circle with a radius of 2. A circle with the radius of 2 that's over the origin has all symmetry. So that's that one. Now, just so you know, an origin symmetry would look something kind of like this. Okay? And so there's my xy coordinate. It has its mirror image down here, negative x, negative y. So when I plug in a negative x cubed, that's a negative x cubed. So if it's exactly, and to check for origin, we need to plug them both in as negatives. So negative y equals a negative x cubed. That gives me negative y equals negative x cubed. If I divide by the negative, or multiply by negative to all of this, that gives me y equals x cubed. So if I were to do that on part D, if I replace the y and the x with both negatives, negative y equals 1/3 negative x minus 1, that gives me negative y equals negative 1/3 x minus 1. Now to get y the same, I multiply everything by -1. I get y equals positive 1/3 x plus 1. So see how that plus 1 is not the same as my original equation? That means it's not odd symmetry. Okay, there's not origin symmetry. So when we do this, when we replace y and x with negative y and negative x, when I'm all done, I need to get back to the same equation. If that happens, so we're replacing x with negative x and y with negative y, when I simplify that out, if I get back to the same original equation, then I know that it's symmetry with the origin, or odd. The function is odd. So anyways, just a little bit of a side note on that one. You can do it by just graphing them. I was just showing you the algebraic way to do all of those as well. So we just talked about this kind of. Remember, odd means origin symmetry. Even means y-axis symmetry. We just call the function even or odd. If it's not either of these two, it's neither. So realize that this has symmetry, but this is not a function. And so we don't say it's an even odd function because this is not even a function. So realize that's the difference. When we're talking about symmetry, we're just saying, does the graph have any kind of symmetry? When we're talking about even, odd, or neither, we're talking about functions. So this is not a function, so it cannot fit into our category for even or odd. So now looking at part A, again, the easiest way is to graph this. So if I graph this, it looks like this, which is origin symmetry, which means it's odd. Again, checking for it algebraically, if I replace this x with negative x, and replace this x with negative x, and replace my y over here, so let's just say that's y with negative y, I would have negative y equals negative x cubed minus x. If I multiply this by a negative, I get positive y equals positive x cubed plus x. Oh, I forgot to put the -4 out here. So that makes that positive 4, because a negative times a negative makes a positive. And then that would make this, when I multiply everything by a negative, negative. So that brings us back to our original problem. On this one, so if I were to have negative y equals the square root of 4 minus negative x squared, so I'm testing for odd symmetry. Negative and negative makes a positive. That makes 4 minus x squared. And then negative y. Well, that's not the same. This part over here, the right is same, but this left is negative. It's not going to make things the same. If I replace x with negative x, though, so just that part, then I get a positive out of negative times negative is a positive, and it gives me the exact same thing as what I had to begin with. So if you can replace x with negative x and you get the exact same thing, then we know it's symmetric with the y-axis, which means it is even. And you could have graphed this, and you get half of a circle is what you get. Part C, if I graph this, I move right 3. It's a parabola. That doesn't have any symmetry, so that's neither. And you could do it algebraically as well. So we're going to graph all three of these equations. Negative 4x plus 2 means I start at 2. And I go down 4 and over 1. So I could have really gone left 4 and over 1. That's 4. 1, 2, 3, 4. 1, 2, 3, 4. And so forth. So this thing looks like this, kind of. Now x squared. So far I have not even worried about the rules on the right hand side. I've just gone ahead and graphed it without any regard to rules. 3 squared is 9, so that's 4, 5, 6, 7, 8, 9. Some symmetry going on here. And finally we have 5. So I come up to 1, 2, 3, 4, 5 and draw a straight line. It's supposed to be a straight line. That's a little better. Not great, but better. So it says to use my red one when x's are less than -1. So -1 is right here. So what that means is I'm not supposed to use my red one. That should be an open circle because it says not equal to, for anything that's over on this side. So get rid of my red one and put an open circle right there. This one for x squared, it says use it between -1 and 2. So between -1 and 2. So I get rid of everything that's to the left of -1 and everything that's to the right of 2. And those are filled in circles. And then for 5, it says for anything greater than 2. So I get rid of everything that's not greater than 2 on my x-axis. So these values over here are less than 2 on my x-axis. And this should be an open circle. And that's my piecewise graph. So anyways, look at your rules between -1 and 2, between -1 and 2, greater than 2, less than -1.